I'm tripping so hard.
Yeah. It's a Jimi Hendrix video.
All you hear is play some Fractal videos on YouTube, please.
Pink Floyd, Dark Side of the Moon.
Yeah, right.
That'd be a good Friday.
Yeah.
There's one we should-
This is a great first week, you guys.
We microdose and listen to the 70s music every Friday.
Really helps build the team. Get more empathy for each other.
Oh, shit. Oh, I need to be somewhere.
Does anybody have a laptop they can test the link out on?
I can see
Paper.
I can see it great.
I just posted a link to Slack. See if it's actually showing my screen now or the Versailles Windows Hall of Mirrors. Is that what they're called? It's showing this?
I'm not hanging out there. It says off air.
Seriously?
Seriously.
Yeah.
Okay. Wait,
Up.
wait.
Yep. Whoa.
That wasn't it.
Okay, so now is it showing my spreadsheet?
Yes.
Okay. I shall present.
Should you turn your speakers? Can you turn your speakers?
I want the Windows bag.
This is, you have to get through the harsh too.
Steve, can you hear me? Did it? Anything
No.
Yeah,
Well,
you're-
I'm on mute.
You're on mute for talking or mute for everything?
That's working.
Okay, that's great. All right, we're going to start. There's no sound, whatever. All right, clever pun, life in the fast lane. Advanced serverless computing. I was going to do some, I didn't have time to do graphics. I was going to do World Lambda, like World Blend. So brief overview, we're going to do a quick review of the serverless computing presentation from last summer. Then we're going to do an update of the different various function as a service providers. We're going to do an update of the tooling and frameworks and ecosystem around those services. And we're going to do two demos. First demo is Chalice, which is a micro framework for Python and basically creating REST APIs with API Gateway and Lambda. Then we're going to do a demo of the more full-featured serverless framework. Both of these are going to be very quick, short demos. And then we'll present further resources, which are some good links. All right, there's a link to the previous presentation here. It's also linked off of professional development wiki page. If you want to check that out, it's more basic than this one. It just covers like basically the concepts of serverless computing. But just to review, serverless computing does not mean that there's no servers. Basically what it does is there are new deployment models possible now that the container ecosystem is risen. So serverless computing does mean that there's less servers for you, the developer, to manage. The underlying provider is responsible for all infrastructure management, or most infrastructure management. What this does is this reduces the overall server management burden for a large set of use cases. Serverless computing is kind of a generic term. It doesn't really have a precise definition, kind of like cloud computing. But there are a few different models that kind of fall within this umbrella of serverless computing. Probably one of the most widely used one is mobile backend as a service. Example of this would be Firebase from Google, old Parse service, which was bought by Facebook and shuttered. And there's a few other examples of that. Some of the more advanced platform as a service platforms could also at least partially be covered under serverless. These would be like OpenShift, Heroku, Iron.io, and a few more. API mashups, don't really worry about those. Function as a service is the one we're going to talk about today. That's basically serverless computing a la Lambda, Azure Functions, etc. So function as a service is one example of platform as a service for the container world. It's a natural evolution of advances made in operationalizing and abstracting container infrastructure. So basically, the rise of containers, largely popularized by Docker in the early teens, basically enabled sub-second startup times of container workloads. And this basically enabled function as a service where you could basically bring up a function, execute it, and tear it down in sub-second time. That basically led directly to the ability for this computing model to be used. Some characteristics, you provide just code, provider handles infrastructures, auto-scaling, etc. Functions can be triggered synchronously or asynchronously, subject to events. Your functions are stateless, but they do integrate possibly with other stateful services. And there's the potential to save a lot of money, as one of the benefits of this is you're charged for the resources you use rather than the uses that are allocated to you. So for example, like we pay about $5,000 to $7,000 a month just on our AWS bill. And most of that is like VMs for development purposes that are probably being used like 2% of the time. So if we could find, we probably couldn't find a way to do a lot of those VMs in Lambda, but if we had like actual workloads that we could you know, port to Lambda, we could lower our cost to like probably less than 1,000. It's pretty amazing how cheap these Lambda calls are. Some caveats to this, not every workload is a candidate for function as a service. There's some issues around first-run latency, and latency in general. If your application is very sensitive to latency, it might not be a good candidate for Lambda because since it's stateless service, anytime it touches state or cache or anything else, it's going far outside of the actual code, so it's going to impose a certain amount of extra latency there. There's also, if your service hasn't ran for a while, it's got to spin the container up, which takes a little bit of extra time. And so that's like basically a cold run. So what a lot of people do as a hack around that is they'll just send like a ping every 5 minutes or so to their service to keep it warm. But there's no guarantees around that, so it's kind of just, like I said, a hack. You have limited environmental flexibility. You can only basically target platforms or languages for specific versions, and for sometimes like specific vendors. Like, for example, Lambda only supports OpenJDK. It doesn't support Oracle branded Java, which is typically what we use here. There's no direct access to the server environment, so this makes like debugging and monitoring pretty difficult. Tooling is improving in this area, and we'll talk a little bit about this later, but it's still not there in terms of being able to debug your code like you would do with your debugger. It's not quite where you really want it to be. There's also lack of mature developer ecosystem around like frameworks and that kind of thing. That's also improving, but not quite as fast as I expected, at least. So these are basically cloud service, function as a service providers. AWS Lambda wasn't the first, but it was definitely the one that popularized this model. It GA'd at Reignite in November 2014. Really, the only thing since last summer in terms of the cloud service that they've added is basically this new thing, Lambda at Edge. And so this basically is where you can run Lambda functions at CloudFront edge locations rather than just at their full service data centers. And this is only supported for Node.js right now. So, yeah, network latency. So yeah, so basically it's like a CDN. It's CloudFront, it's a CDN, so you can run, I don't know, they have like maybe 100 edge locations around the world as opposed to like maybe 13 data centers. And so it's much closer to the user.
But it's running in responses and having requests that figure out the closest edge location.
Yeah. Yeah, so that's the way the CloudFront works in general. But before, CloudFront was just static files, but now you can run these Lambda functions if they're written in JavaScript there too. So before you would have to, if you're you had like your website calling a Lambda function, it might have to go farther to get to that Lambda function, whereas now it can just go directly to the CloudFront location. So that's pretty much the only major feature they added since then. Azure Functions, since we last spoke, did go GA in November. It's basically a direct clone of Lambda, even down to the pricing model. Google Cloud Functions is finally went beta a couple months ago. So given their track record, that means maybe it'll go GA at 2025. Pricing model is very similar between all of these. Typically, there's a charge per invocation beyond like a free tier. That's true for all three of them. Then you pay basically for the amount of resources used per invocation. And that's usually just the compute time times the amount of memory used for each invocation.
All of them limited to 5 minutes?
No, that kind of varies too. So yeah, those parameters vary a little bit. I don't remember exactly what they are for Azure or GCF. But, and GCF also actually charges for outbound data transfer, but I think the others do too. It's just not mentioned specifically. I think it's just part of like the overall bill. So don't quote me on GCF being the only one for outbound data transfer. As you can see with supported languages, GCF definitely has the least amount of features. The only thing it supports is JavaScript. And they say in their documentation, it's still beta because they're still changing things around, trying to figure out how they want the model to go. So I wouldn't expect any more languages until it goes GA. See, I don't think there's anything else interesting there.
You don't have anything about it.
I do in the next slide. So these providers are also available on-prem and hybrid deployments, and also some of them on cloud service, like OpenWhisk by IBM is actually available as part of the Bluemix, which also allows for integration with Watson. So that'd be an interesting use case if you were going to like upload a video or something and have Watson like look through it and like, you know, do some machine learning on what's in the actual video. That'd be kind of cool. So OpenWhisk was created by IBM, donated to Apache, so it's now an Apache incubator project. I don't think it's actually accepted full status yet, but it's open source. They're trying to get people to contribute to it, but you know, it's IBM. It's kind of they don't really have great relationships with a lot of developers. Anyway. Other interesting things about it, it actually has the ability to run locally, so you can get much better debugging services or debugging support than the cloud-based function as a service. So you can actually like run it locally, attach to it with a debugger, that kind of thing. So it's a little better in that sense. And you can use it for cloud and hybrid. So you know you could do on-prem. You could if you're running out of compute resources on-prem, then you could just throw it over to the cloud. Another interesting thing is that it supports Swift, which means iOS application developers or app developers have the same advantages of like JavaScript and Node.js developers, where you can write in one language, front end and back end, use reuse code, all that kind of thing. It also has the ability to just throw a container image rather than just code and have it work. That. Iron.io was one of the earliest providers of serverless computing, basically in the early teens. They started out providing just a hybrid platform for asynchronous and batch workloads. So a company needs to do some kind of workload that doesn't have enough compute on premises for. They would use their platform to transfer the workload to Iron.io, and they'd return results back. So they have a pretty strong platform. I don't have too many details here. Kubernetes, there's a bunch of projects that are springing up to provide function as a service support to Kubernetes. Kubeless, Fission, and Function are the three I've mentioned here. But it looks like that's going to be something that probably will get put into first-line support sometime in the next year or two. AWS has a few experiments for on-prem use. One is Greengrass, which is more for Internet of Things devices, but basically it's software that your Internet of Things device will be able to perform local processing on the data it has, it's collecting before sending that up to the cloud. And so that will have some Lambda support there. It's in limited preview. And then your snowmobile, that's the big suitcase of data and also the big truck of data. They both come with, in those actual suitcases, there's compute units that can run Lambda code on your data as you're migrating it into the Amazon data lake. So that allows you to do like dedupe and all sorts of like processing to minimize the amount of data so that you're spending less transferring it into Amazon. But they don't have just an AWS like appliance or anything like Azure Stack. So Azure Stack is basically all of Microsoft's Azure, maybe not all of them, but a lot of Microsoft's Azure services, you can actually run them on-prem. That's called Azure Stack, and it now supports Azure Functions. Okay. So some trends in the tolling framework space. So all the service vendors, they're trying to improve like their basically first-party tools for deploying, monitoring, and debugging. There's some tools that are coming about to do more multi-cloud support. So if you don't want to be locked down to a single cloud vendor, or if you want to do like a hybrid architecture. And then, as I mentioned, more and more tools are being written for local running and debugging. So to dive into those a little bit. So AWS Lambda, there's a lot of different tools for manipulating this. These are all first party. So you have the GUI, which is the management console. You can go in there. You can just navigate menus and set up integrations between your Lambda function, between like say API gateway or some other type of event. And also you can have it integrate with any of the other AWS resources like databases or whatever. So that can all be done via the GUI, but it's going to get pretty time consuming.
So you had on the previous slide, AWS Lambda has got many languages. Is that correct?
Yeah.
Got many languages, not just. I thought it was just ours.
No. They've had a bunch. They have a so Python, JavaScript, PHP, Java, C#, and executables. And if they don't have something that you want here, you can usually shim it using like JavaScript to just like launch an executable or something. So there's all sorts of hacks to get like Haskell or whatever else in there if you want it. There's a couple of Go hack. Are you talking about those frameworks? Yeah. There's a couple of frameworks that are just around Go hacking. I mentioned a couple of them later on. All right. So you probably don't want to do GUI more than once or twice, just to get an idea of how they all fit together. So AWS has its first-party CLI, which is the good old AWS CLI that everybody uses. And then they have something called Serverless Application Model. What that is it's an extension of CloudFormation, which is used to define integrations between your Lambda functions and other AWS services. What this basically is a YAML file. It's just like other CloudFormation stuff, except you're putting in, or you're defining the Lambda function and the services it connects to. So if anybody's actually used CloudFormation, it's not exactly a friendly tool. So there's still some work to be done here in improving the first-party tooling for deploying services. So there's this new thing called step functions. So basically what this is it's state as a service. So if I got a bunch of Lambda functions out there and I want to put together an app where like this function calls this, and then this function, depending on what was passed, calls either this function or this function, that's really hard to do, or it gets complex if you've got a lot of network connections there. And there's other issues like while your first function is calling the second one and waiting for a result, it's still running. And so you're getting like triple build, or however many nested functions you have, you're getting n times build for each execute. So it's a big mess. So they came out with this step functions thing, which is basically an abstraction around SQS. where you can basically build state machines with a JSON specification. So you can say like this this function sends information to here, then state transition to here based on this. So it solves that problem, and it's very new there. So it hasn't been used by a lot of people, and there's like some issues with it that people are starting to realize. And so I put a link to an article here, which is like some guy took a look at it and said, it's a good idea, but it's not quite there yet. Some of his issues were that it costs way too much. It's like each step function or step transition is like 125 times the cost of an actual Lambda. So it's not something you'd want to do very high numbers of. And there's other issues, like there's a limit on how many state transitions can happen in a second, and it's like really low, like 2 or something. So it's like it's not quite ready for prime time. But the way AWS always does it is they start off pretty shitty and they get less shitty, and then 3 years later it's usable. So maybe by like next year, step functions will be a thing. Hopefully you don't have to use them in WB. So CloudWatch integration is another aspect of tooling. This basically has like very broad level logging and metrics. They did come out with this new tool called AWS X-Ray, which is much finer grained metrics, performance data, tracing of Lambda calls, and it also includes all of the upstream and downstream calls from your Lambda function. So basically it kind of provides like an APM style visualization of data around your Lambda function. And it has the ability to create like subsegments of your function. So you can say, I want to see how much time was spent in this like for loop or something. So you can put in some instrumentation to do that kind of thing. Only in JavaScript and Java, but not for any of the other languages.
The CloudWatch is that essentially like you do log aggregation, right?
Yeah, but you can do log, but it's very the opposite of fine. Coarse grained logging, and it may not give you all the data you want.
Right.
It'll give you like the number of times it was called, but maybe not like.
Right. That's supposed to be monitoring the actual entry into AWS stuff as opposed to like application.
Yeah.
Do they have a product that is log aggregation?
Well, they have like Elk Stack. They have like Elasticsearch. I'm trying to think if it's. I think you can do Elasticsearch around like CloudWatch. I don't know. They have basically all the components of an Elk Stack, and I'm not sure whether they have a managed Elk Stack or just managed Elasticsearch. I'm not 100% sure on that. So, but definitely you can pipe CloudWatch into something like that. Okay. All right, Azure Functions. So Azure has a GUI as well. They call it Azure Portal. They have a CLI. The CLI is much better organized and makes a lot more sense than Amazon's. Azure Resource Manager is basically the same thing as AWS CloudFormation. So they have like basically the same tooling around that. One thing that they do have that Amazon doesn't have is integration of Visual Studio. So I know some developers like that. They have Azure Monitor, which is basically the same thing as CloudWatch. And then they have this local testing and debugging with Azure's Functions Runtime. So this requires new Windows, basically, a SQL Server, but you can do your local testing and debugging there. Okay, Google Cloud Functions. It's much more primitive still, although they do have a local emulator that's, I think, in preview mode or something, or preview stage, preview status. It's like Google, everything's in beta. So, but you can do testing and debugging using the native Node.js debugger or the V8 inspector, which you front-end guys may know what that is. But we don't have any front-end guys. Are you a front-end guy?
Yeah.
Okay. You know what that is? V8 inspector. So it tastes a lot like kale, right? I can read the ingredients list.
What up?
Salt, corn syrup. Frameworks. So serverless framework is still the kind of like the the number one right now, primarily because it's a VC-backed company, so they get money and they can pay developers. Right now it supports 4 different providers: AWS Lambda, Azure Functions, Google Cloud, and OpenWhisk. So Sparta is when I was talking about the Golang framework. Basically, you can have an entire Golang application, and then this thing divides it up into like functions using like Node.js shims. So I guess it has like Node.js point to like certain areas in your Go binary, but then I don't know. Yeah. So same thing with Apex. So there's like 2 frameworks that do this weird thing. So apparently, yeah, apparently it's a thing. I mean, I don't know how many people use this, but we mean by cool with it.
Well, they're not about to stop them.
Well, of course, you're not going to stop them. You want your ecosystem to build up. But yeah, so if you're into Go, those 2 look kind of nice. Chalice, which we're going to look at in a demo, it's very simple framework for Python plus Lambda plus Gateway. There's one called Serverless Express, which I guess Express is some framework for JavaScript front-end programming.
Yeah.
Is that used at all?
For Node, this is like something.
Okay, so number 1 for Node. Okay. So yeah, so that's an NPM module for having your Express framework call or deploy to Lambda or something like that. I don't know. There's also a Java container, which you can take your Java app that's written in Jersey, Spring, or Spark, and that'll do it for you. Is that useful?
I mean, I can see how that could be. I mean, for one thing, depending on how flexible that is, you might be able to like test locally using Jersey and deploy on Lambda. I mean, no idea if that's really what this does, but
I didn't pick it for a demo. So. All right, Chalice demo. So, did you get to use Chalice?
Well, the one thing that they mentioned about Chalice is that it's the only one that provides opportunities. So like the link that I'm comment was I am mission is just pointing out issues X-ray. But with Chalice, it helps.
Yeah. So Chalice, if you've used Flask, which is like a Python framework for REST APIs, it's basically the exact same programming model almost. So it's basically intended to be used for just creating really fast REST APIs for Python that are backed by Lambda. Prerequisites: Python 3.6. I think it's also accepts 2.7 as well. And you have to have an AWS access key plus CLI. It helps if you're an administrator, so you can create all the IAM roles. It's not necessary, but you have to do some workarounds if you don't. So we can do a demo here. This is going to be, no. Okay, so first thing to do is your Python 3 is installed, then you pip install Chalice, and Bodo 3, which is the Python AWS SDK. And you run this command, Chalice new project, and we're going to do a FizzBuzzard project. Okay. Sudo Chalice. Oh, Pat Buzz. Okay. Okay, so this basically just creates a boilerplate for you. Requirements set text is just the Python module dependencies. If you look at this, okay, so if you look at this, basically all it does is it embiggen. Oh, I know. What is this? This is like the weirdest hotkey. What is that? Apple equals? Oh, Apple equals. What is alt? No, option? It's not appear right. What's that? It's not doing anything. Okay. Could you wiggle it a little bit? You make text bigger. Oh yeah, Apple Plus. There we go. Okay. So creates this object called chalice with a name, and then it defines a route. So the default is just to print hello world, or return a JSON hello world. Gives you a few more examples of usage. So you can do, a get parameter here, and then you define the function. Your first get parameter is the parameter of the function, blah, blah, blah. Then you can reference it and return something. You can do post method. Okay. So you get the basic idea.
Tell us as soon as you're using it.
It seems to be the only point of doing it because it's basically just API gateway plus Lambda. And then, okay, so I'm just going to deploy this hello world thing. So just chalice deploy.
That's some good super code.
Yeah, it's crazy how fast it is. Very well. Okay, so it gives me back an endpoint. I curl that. Oh, I forgot I have a mouse. Sweet. Get back hello world. Yay! Okay, so like I mentioned, this only worked because I have administrator access from API key. And we don't really want to do that for everybody unless we started creating separate accounts for everybody, which gets another pain in the ass. Anyway, so if you want to run it locally, you can deploy it to chalice local some port, and it'll basically it's just like if you've used Flask, it's the same thing. It just runs in the foreground, and then you open another window and hit that endpoint, and blah, blah, blah.
No idea what this deployment model is.
So this is actually creating IAM roles, and
Right, but once those roles are set up, if you
there, like I said, there is a way to get it to say use these pre-made ones. It's a pain in the ass. We would do that if we were doing this in production or something. What we would do is we would do that in the CI environment. We'd have people develop locally using the local, and then in the CI environment, we would actually either, I guess we could use administrator credentials at that point, or we would set it up so it's using the pre-created ones. So. IAM. Identity and access management. It's one of all the armpits that are buried in the AWS. So it's probably the hairiest armpit, stinkiest armpit. All right, so I wrote this demo. In the interest of time, I'll just show you. So basically, you pull out that code for the index route and add fizzbuzz plus a get parameter here, number. You do your fizzbuzzer code, pass in the number, blah, blah, blah. Turn an output string. And then to redeploy, all you do is run chalice deploy again. And it should look something like this.
Is that initial one that you created still running? Or did you put that?
It is. I haven't killed it. I'll kill it later.
How did you put it?
Chalice something, delete, remove. I don't know. I'll look at it.
So it's using CloudFormation.
Yeah. Yeah. Okay, so this should be my fizz buzzer. So if I do curl this /2, you son of a. Oh, that's a different error. That's something else. That's something else.
Did you say select phase buzzer?
Yeah, that's what it was. Because I gave it a route, right? Was it fizz buzz or fizz buzzer? Okay, yeah, there you go. So it gives 2. You do 3, if you give fizz. If you give 5, it'll give fizz buzz, or no, give buzz. If you give 15, it'll give fizz buzz. If you give at @foobar, it should give an error. Yep. All right. That was fun. So the point is, using this, if you just want to throw up like a really quick, easy REST API using Python, you can do this in like 2 minutes. And it auto scales and all that kind of crap. So okay, so additional features. So the integration with additional AWS services, the only thing that's like really provided as part of the framework is just the API gateway and that stuff. So like if you want to do like database, all that stuff, you're doing it through the Goto API, so it's not that convenient, but it's still doable. But you might want to start looking at something more complex if you have those kind of needs. There's some debugging support. You can set a debug variable to true. You'll get like stack traces and stuff. You can do any number of HTTP methods. You have core support. You have finer grained IAM control if you want it. You can do authentication using API keys, incognito, which is like their single sign-on SAML thing. Local execution we just covered. Chalice delete is what do you say? That's like their SAML, SSO. It's like integration with other Cognito, it's AWS service.
Okay.
Yeah, one of their 50,000 services. So there's user pools and auth handler. I don't know what the difference is because I've never actually used it, but one of these has Google Auth, which we're going to switch everybody over to. It's added support for that like last year, and so we never did that because we opened our account 3 years ago. So. Chalice delete is the end deploy. So. All right, so let's go into serverless framework. So serverless framework, kind of similar. No, it's not really similar to Chalice, but it's basically much more full-featured. It has support for a number of languages: JavaScript, Java, Python. You can deploy it at Lambda, Azure, Google, or OpenWhisk. It's opinionated, and it has like repository structures and YAML files and all that kind of shit. So the concepts, so functions, code that is deployed is basically a function. Ideally, you break it up so it performs a single task. You can use this one single YAML file to define multiple functions. And it's a good fit with microservice architectures. I didn't get into it, but you can also like do Swagger stuff and have, define stuff as your API gateway stuff in Swagger, but I didn't get into that. An event is something that triggers a Lambda function execution. So normally you think of this as like the canonical example is like you upload something from S3 bucket, that triggers something that happens, or a CloudWatch event. But they also include like a REST API request as a triggering event. So when you're configuring these things and you want to just do like the same thing, like fizz buzzer for this, use REST API as your event type. You can also do timers, so you can set up cron jobs, that kind of thing. Resources, you can basically use any AWS resource for your Lambda function that's definable with CloudFormation. So they end up basically including just straight CloudFormation code inside of their bundle. So the downside of that is you have to know how to do stuff with CloudFormation. A service is the framework's unit of organization, and a service is defined in the serverless.yaml file. So like typically you'd organize it so you have a directory that has a serverless.yaml and then like some code and then maybe some events or whatever else. And it also supports plugins, so you can extend the framework. All right, so prereqs, Node LTS 6.1 or 6.10. It's an NPM module as a command line. So basically it's a command line tool. So So again, there's issues with IAM. They kind of punt it and they say, in a production environment, we recommend reducing the amount of permissions you give the user. But unfortunately, we have no idea what our actual user needs. So, so this is still early days and all this stuff. So like nothing is really very polished. And so basically, I run this as administrator, the same as I did the other thing. Otherwise, it's going to break. Supposedly, this is like invoke local command. Did you ever run that?
Yes.
So invoke local command is similar to the local one for Chalice, which it'll run your function locally. So to create a boilerplate, the same way we did Chalice, you do serverless create. You give it the template, which is the language type, and then like the path/name is whatever you want to call it. Other options: Node, Python, Groovy, Java, both Gradle and Maven, Scala, and C#. So what's that? Yeah, it's like one of the only ones that supports it. I guess I'm editing this already. Let me see that. All right, so here's what a YAML file looks like. Service name, provider, so this is AWS. The runtime is Python 3. Default region is US West 2. You can also set like the stage, dev, prod, whatever. These are basically your IAM roles for the third-party or the other resources that your function uses. You can set environment variables. Here's where you define the endpoint or entry points into your function. There's a second file in the same directory called handler.whatever type of language it is, and that'll have like the fizzbuzz entry point function. Here's where you define the API gateway route information. So basically, we're going to give it the path fizzbuzz / a number. It's going to be a get, and we're going to require that number is there. Here's some other things you can do. You can schedule it. You can define a bucket that it talks to, whatever, CloudWatch events. These are like basically the list of events. Remember how I said like the event that triggers it is the API gateway call. So that's what this is right here. But you could also, like this would be like uploading to a bucket. This is on a schedule. This is like publishing to a queue, blah, blah, blah. CloudWatch event. Yeah. And other things you can configure are like billing tags, memory size, versioning, timeout, DPC, that kind of thing. All right, so the other file in there is a handler.python. In the case of the Python, it contains the actual function code. You can also have an event.json, which is sample event data that can be used for testing. So here's basically, this is just basically a function that takes in an event in the context. These are basically the input parameters from API Gateway and does stuff with it and then returns something. So the edits I made were to add the routing information to the serverless.yaml file and then edit the handler.py. Before this had just like the hello world example. And to deploy it, package it, or to build, package, and deploy, you do serverless deploy. That does the same thing that the Chalice did, where it basically provides you an endpoint back, and then you can run. Oops. Whoa, what just happened? What? It increased the size of everything but the fucking display. Okay. All right, so gives you back a REST endpoint, and then you can do basically the same curls, and you should get the expected information. So some commands for serverless framework. Serverless create is create a new service. Deploy commands are deploy. You can deploy the entire thing. You can deploy a function, just the function part, which would be quicker. And then deploy list. List your deployments, right?
Right.
Yes. Remove removes the Lambda function and everything else you deployed. You can do rollback if you want to roll back a version. Serverless invoke will actually run it on the actual cloud service. Serverless invoke local will run it on your local machine. For debugging and monitoring, you can do serverless logs. This is basically just a tail logger. So anything sent to serverless on your local machine will get pasted into this terminal window if you're running this tail. It's basically tail-f for any serverless command. You can also use the -L option to serverless invoke, and it will do it in the foreground rather than this one, which is in the back. You can do serverless metrics and SLS stats. I didn't play around with those. I don't know what the difference is between them, but some kind of metrics and stats. Awesome. So here are some further resources. The best one of these is the first one. It's basically a GitHub page where they're updating like a curated list of serverless information, links to various things. But this is probably, that would be your starting place. It's an AWS white paper. It's kind of old, but still useful. There's a conference that's held 3 to 4 times a year. It was held last month here in Austin. But you can go to that page and you can get like videos from past conferences. They haven't put up the videos from Austin yet, but hopefully soon. Serverless Stack has a bunch of tutorials for serverless React apps. Serverless Code is a very infrequently updated blog. And there's a book, AWS Lambda in Action by some Italian guy. Questions? Lamentations? Rotten Tomatoes?
One thing that I learned about Lambda that was surprising to me is that you get a closure rate. And so in the GUI, it looks like just a function.
Mm-hmm.
But in the through one of these frameworks, you get multiple functions, and you can wrap it in closure so you can initiate the database connection, keep it live and stuff. So it's a lot more than just a function.
That's interesting, because I know that one of the issues with Lambda is that you can't really do connection pulling. So I don't know. If you have any information on that, I'd like to see it.
I haven't tried it.
Okay. Cool. Anything else?
Awesome.
All righty.
Thanks, man.
Thank you for sitting through this. Yeah, I wanted to do some better examples, but it's hard to do in an hour presentation.
Yeah. I'm not sure.
Yeah, I kind of figured that too.
Yeah. But maybe the use case events will be more of that. What are you going to use this for?
Yeah.
It's still